There we go. So, good morning, everybody. I hope we're all good today. It's not morning for some of our presenters today. It's what I think it's evening and maybe a different kind of morning for some of the presenters today. So that's awesome that people are so happy to come along and talk a bit about what they're doing today. So this is the agenda for today. We're going to have a presentation from Scott on Azure Orkestra. He'll be talking a little bit about that and how they use Argo inside that system. Then we are going to have some kind of short, I say lightning demos, so typically like 3 to 5 minute long demos of some new features. And this section of that's lightning. This section of the community meeting is new, and this is kind of an opportunity for anybody who's working on new features for Argo workflows or Argo events to kind of come and show off their work and what they're working on, and also kind of maybe gather a little bit of feedback as well. So we're going to have hopefully three lightning demos on that one. So Basanth is going to demonstrate a new kind of extension to how we do RBAC that allows you to set up RBAC SSO, but have the users configure that RBAC rather than requiring a system administrator. Thank you, Kenny. And then JP is going to be talking a bit about pod names. Pod names is kind of a beta feature in version 3.2 that, so pod names v2, which basically means that pod names, rather than kind of having kind of auto-generated names, the name is now based on the template that's executed. That's to kind of help users with debugging their pods when they're running. It just makes it, especially for simple workflows, really easy to find them. And then if there's time, I'll talk a little bit about some of the plugin proof of concept and work that I've been working on this week. If you have a question, you can obviously ask that, or feel free to, typically people often wait until the end of like a presentation or demo to ask questions. That's a good time. And you can obviously follow up on Slack if you want to ask more questions. If you want to watch this later on or share it with anybody, I will hopefully put the recording of this on to YouTube either today or tomorrow. Depends how long that takes to upload. And I like to add the kind of marks in it so you can skip to the bit you're particularly interested in. That starts at 2 minutes or 3 minutes. So that allows you just kind of deeply link into those videos. And I'll share that video on the Slack chat later on. Any questions before we get started? Scott, are you ready?
I am. Let me
Brilliant.
share my screen.
Okay, I'll stop sharing so you can start sharing.
Can everyone see this okay?
Yes.
Okay, perfect. Okay, today we're going to talk about Azure Orkestra. I'm going to make the assumption that most folks on the call have not heard about this. So we're going to go from the beginning and then go through where Argo plugs in. So this, the slides are not changing. Oh, good. That seems strange that my internet. Oh, here we go. Oh, I'm too far. I do not know what's happening. Sorry about this. Actually, I'll just stop sharing for a second and see what's happening. Won't be a second. Sorry, I'm just trying to get this.
Okay, we'll take a few more moments. If you still have issues, then maybe we can move to the lightning demos and perhaps come back.
Yeah, I don't know. It seems like Zoom. Yeah, maybe if you want to move to the lightning demos and come back, it seems like every time I share my screen with Zoom, it's taking up all my bandwidth. I'll just have a quick look at it.
Cool. Okay, let's just I'll give you a few minutes. We'll maybe go through and do the lightning demos and come back. Okay, so on to the lightning demos. So our first demo today will be of SSO RBAC, and I'm hoping we will not have any more screen sharing issues. Basant, do you want to take over?
Yes, I can do that. Okay. Hello, guys. Good morning. Good evening. So yeah, just a quick intro about myself. So I'm Basant, and I've been working for Intuit about 4 years now. I'm a senior software engineer, and currently I'm working on a product called as QuickBooks. And within QuickBooks, my team currently works on reporting. Just a bit of background around how we have been involved. So basically, we have about 50 to 60 workflow templates that we have written using Argo workflows, and we use it for things like starting AWS EMRs, or orchestration jobs within AWS EMRs, debugging messages on Kafka, doing DB schema upgrades, and a lot more things. So yeah, as of now, I would believe that my team is a very prominent user of Argo workflows, and yeah, with that, we have been very happy and trying to contribute some of the things. Okay, so moving along. So today I'll be talking about what I would like to call SSO RBAC namespace delegation. So yeah, as the name suggests, this feature revolves around the SSO RBAC capability that was added into RBAC, Argo workflows. Okay, so yeah, this is the agenda that I've planned. So I'll start with a quick recap of how SSO RBAC works as of today. Then we'll go into the typical Kubernetes setup that we have at Intuit and the SSO use cases that we have. And then we'll talk about the problems that arise with the current RBAC implementation. And then we'll talk about the new feature and moving on to the demo. Right. So just a quick recap. So this is how users today configure SSO RBAC. Right? So essentially, the person or the team that is installing Argo basically configures service accounts in their namespace, typically the Argo namespace. Right. So you would basically create, say, service account for admin user and provide it with an RBAC rule and RBAC rule precedence. And what you're saying is, if the person has a group that's called admin. So essentially you will associate the user with this particular service account. And after this association is done, you will use this particular service account and the associated role to do the operations in the workflow. So just to show, right? Okay, let me. Yeah, so yeah, this is my local environment, and here I've configured a service account called Argo server, and this is some RBAC rule. And when I try to log in essentially with Dex in my local environment, I'll be able to just do that. And so currently this particular service account has permissions only for Argo namespace. So that's why when I try to log into any other thing, it just gives me an error. Right. And you here in the user section, you'll be see that a service account used this Argo server. So this is the just a quick recap on how RBAC works today. Now moving along, so this is the typical Kubernetes cluster setup that we have at Intuit. So typically a specific business unit is given a Kubernetes namespace, and it typically has say one namespace for Argo installation, and then there are different services that are deployed in the Kubernetes namespace. So for example, here you can see that service one has a couple of namespaces. So basically this is a logical grouping of namespaces. So for service and for each service, there are different Kubernetes namespaces that are associated. So you can see basically like 2 pre-prod namespaces and 2 prod namespaces. And this particular whole namespace is managed by, say, team 1. And likewise for service 2 and team 2. Now, the use cases that we have are that some members in team 1 have to be given say read-write permissions only in the pre-prod namespaces, and some have to be given read-write permissions for all the namespaces, including the prod namespaces, and so on and so forth. And so yeah, this is like pretty much easily configurable. So you can just add a service account in the installation phase namespace and get your thing right. But there are some things when there are some use cases when things get complicated. For example, when a person is, say, he belongs to say team 1 and team 2, and he has to be given different permissions based on the requirement. So then what it leads to is you'll essentially need to create a service account per user and a namespace combination, and then try to manage resources, try to manage your permissions. And this typically gets hard because all of that is managed in one single namespace for which your team does not have permission, right? So these are some of the challenges that we have been facing at Intuit with this particular Kubernetes setup and the way how SSO RBAC works today, right? And yeah, like this is what I have listed here. So these are the issues that I've listed. So basically, one is that config is only at an installation level. So any changes that are required will have to be done by the person or the team that installed Argo, and it is basically Alex's team who manages that. And essentially, it is burdensome for that team. And the fun fact is that we have actually mentioned it in our documentation also, that many complex rules will be burdensome on that team. So this was just some funny thing that they just came up. Yeah, apart from that, basically manages config is hard. So hard in the sense, like one user can always be mapped to one single service account, and only that service account has to be used. So essentially, this makes it hard for us to use multi-tenancy. Basically, have this configurations at a namespace level where it can be controlled and managed better. And the thing that I talked about, basically granting different permissions to different users and for different namespaces is cumbersome. So all of these issues is something that we have been facing, and this is what led us to start the new feature of namespace delegation. Cool, yeah. So let me talk about how we have how you can leverage this feature to like better use the SSO RBAC, right? So okay. Yeah, so you'll still be using service accounts, but yeah, essentially you'll have the ability to create service accounts in your own namespace. So there are two things that that you need to answer, right? Whenever you want to grant somebody some permissions. So one is, can a user log into this particular cluster, and can a user perform some operation in my namespace? So for login, essentially essentially you'll be using a service account in the default installation namespace. So you can provide a service rule saying that if the person belongs to say my particular BU, so then grant him the permission to log in. And after that, once he is logged in and he wants to perform some particular operation in my namespace, so then you use a secondary namespace. So here you can see that my namespace is essentially my namespace for which I have permissions to. So I have created my service account with this particular name, and I have attached the right permissions with read-write roles using the role binding. And here I'm mentioning that allow a person only if, say, my team is in groups. So this way, we have separated two things. So one is the login and then the operation part. And the user and the owner of this particular namespace will be able to configure the service account for which RBAC has to be used, right? And yeah, like this just reduces a lot of dependency on the installation team and makes us and basically makes the whole thing self-serve. So yeah, this is how the feature works. Yeah, before I move on to demo, any questions, comments?
Yeah, so one question I have is that, as we said, right, the one service account can be associated with one user. So
right,
how we are associating here to the, like we are saying user in groups, right? So we are creating
right,
each user, different
right,
individual user.
yeah, yeah. Yeah. So if okay, see if I'm a user and I'm making a request in say my namespace, so then I'll be using this particular service account. If I make a request in say a secondary namespace, so then the service account of that namespace will be used. So that provides a way to essentially map like one user to multiple user accounts, multiple service accounts, but they're still belonging to different namespace. And the owner of the namespace has a control to whether to give you permission or not.
Okay, thank you.
Yeah, does that answer your question?
Yes.
Okay, cool. Yeah, I will move on to the demo. Okay. Okay, so here you saw, right? So this is the service account that is present in, say, only the Argo namespace, and that's why I'm able to only perform operation in, say, Argo. And if I switch, then it's like you can't do anything, right? So let us see. So yeah. So let me first create, say, create a new namespace. Say my so yeah, so now I have created my namespace, and here yeah, so here I have a service account that I've created, which is belonging to, say, my namespace, and I've associated with the right role and then the role binding. And let me just apply it. Apply space minus my namespace. So this just creates all of these resources in my namespace for which I am the owner of. And now if I try to log in, essentially I have the permission. So here, while going back, I can just create all workflows, look at them, and the same thing can be applied. And yeah, just to test it out, if I like, okay, so I can say create workflow templates. Now, if I just remove the workflow templates from this permission, and if I refresh, I don't have permission. Right. So essentially it's the same feature, but it's just extended to be at a namespace level and much more configurable by the owner of the owner of the namespace, and yeah, reduces a lot of dependency on the person who installed. So yeah, that was a bit about the demo. And yeah, I've just listed out the benefits of this. So yeah, one is basically SSO configured as user level, and the users can define their config in their own namespace, reduces dependencies, and essentially it makes the whole process self-serve. Like there would be cases where if there are certain incidents where like there is a production incident and you would want to like promote a user to admin and for a small period of time, and yeah, like in the previous way you had to like raise a ticket and yeah, ask the other team, but yeah, now you can essentially do it yourself, and yeah, it reduces a lot of time. The second thing is now like things are context aware, in the sense that the Argo server knows that the person is making this request in my particular namespace. So let me look at the service accounts and the rules in that namespace for which the user has more control. Right. Apart from that, yeah, you can like map a single user to different service accounts based on your context, and they easily manage permissions for different new namespaces. Apart from that, we believe that this is a right step towards Kubernetes multi-tenancy in terms of managing things in a particular namespace. Yeah, so that's pretty much about the namespace delegation feature. And yeah, finally, questions, comments.
I have a question.
Yep.
So how does it know to use the namespaces? Is this automatically scanning?
Yeah,
for
it is automatically. Like, so if you think about it, right? So here, when I say workflows my namespace, so essentially this particular string my namespace goes all the way to the backend, and each and each request object, right? If you see like workflow request or template or workflow template request and everything else. So essentially they have this namespace associated. So using which we calculate, like using which we determine that this is the service, like these are the service accounts which we need to look at and then associate it to the user.
Okay, does it scan for all service accounts with that annotation? And
all
then,
service accounts in the annotation, yes. That is
okay. Then how does the operator actually opt out of this? Because let's say they don't want to, they do like privilege escalation, for example.
Yeah, so that is something which we have been discussing. So like currently what we have decided is basically currently this feature is in beta. And if you want to enable it, you will need to set set this environment variable to true. And if you have not set, then SSO delegate won't kick in. And I think going forward, we can even provide an argument to the Argo server itself, basically to use this feature or not.
I see. Okay.
Yeah.
It's a little bit smart. I was going to just like add one thing to this. It's a little bit smarter than just grepping the namespace out of the URL as well. You can actually intercept the gRPC calls, and you've got structured data at that point to inspect. And obviously anything in the namespace has a get namespace method, so you can duck type it to get the namespace out.
Yep. And just one more thing, we have added a small optimization. So till now, every call made to Argo server used to like fetch all the service accounts from the Kubernetes APIs. And yeah, this basically happened, and basically a single call was made for each of the requests. Now we have just added an informer to just cache all the requests. So going forward, going forward v3.3, you should be able to see a lot less calls being made to Kubernetes API server. Yeah, that's just one thing I want to add.
Okay, so we've got another demo from a new feature from JP. This feature, JP, you ready?
Yep, I'm ready.
Cool. I might just let you take it away rather than stealing too much of your thunder.
Yeah, thank you. So pod names v2, as Alex mentioned at the beginning of the presentation, includes both the template name along with the global workflow name. This is going to be available, or it currently is available if you're only using the CLI in 3.2.123, but the full UI support will be coming in 3.2.4. Let's do a quick demo of it. So if we kind of look at what a normal pod name looks like, if I go ahead and submit a workflow that has like several different steps in it, it will generate pod names that include the template name in here. So we see that the global workflow name is Stag Diamond Steps, and that each of these is invoking an echo template. And this is really useful for like troubleshooting purposes. So if I go to the CLI and I do like kube control get pods and Argo, I can see like each of my workflows that's invoking this echo template. And this just generally is like pretty useful if we notice that like certain pods are or like certain templates are functioning well versus like not functioning well. I can go in and troubleshoot the ones that are like functioning poorly based on the name, whereas not having this information was previously pretty difficult. To enable this, you're going to set an environment variable of pod names equal to v2 in both the workflow controller and the Argo server deployment, and that should be ready in 3.2.4. Real quick demo, but hope y'all liked it.
Thanks, JP. So what we're going to do now is we're going to flip back to our main feature, which will be Scott talking about, hopefully talking about his Azure Orkestra and not about internet bandwidth issues, which we all have, I think. Good. Thank you, Scott. Take it away.
Thank you. Okay, second time lucky. Hopefully this will work better. So a little bit about me quickly, because I wasted a bit of time before. I work for Microsoft. I'm a cloud developer advocate on Cloud Native. I run the Cloud Native team there. So mostly we work on Kubernetes. We do work on some other stuff as well, like WASM and a few other bits and pieces. My passion is container runtimes. I write mostly in Go. I do a bit of Rust now. I collect comic books, and as you can see behind me, I love Funko Pops. I collect those as well. So a quick overview of what we're going to do today is just look at what Orkestra is and where Argo fits in. So I'm going to go through this fairly quickly. This was meant to be a slightly longer presentation, but I've cut it down a little bit. So one of the most important things that we wanted to do at the beginning of Orkestra is it's 100% open source. It covers release orchestration and lifecycle management. It started off with a problem around deploying applications with Helm, but it's grown to further than that, and I'll explain that in a second. So this is the architecture here. It's built with all CNCF projects, and basically what it does is builds complex application DAGs and allows you to do deployments of individual components for your application, including service mesh, including gatekeeper, including storage, including anything by just adding custom CRD into your deployment and then deploying out your application. So what this is, and then you've got, like you can see down the bottom there, you've got Helm, Argo workflows, the Helm controller, you've got Chart Museum, and Captain to do your testing. So this is kind of what the architecture looks like. So you've got the application resource group, which is the custom resource. You deploy that into Orkestra. It will look and see at any of the Helm charts. Argo workflows will be automated. Then it will kick into creating the diag and deploy out your application for you. We've got a staging registry there using Chart Museum as well. So basically what this allows you to do is this is kind of what a standard application looks like. So you've got network layer, security layer. There's a whole heap of stuff that you probably want into your application. And your application might not be able to tolerate Kubernetes, just keep deploying, and then like the reconciliation loop. You might need to make sure that there's certain things there before you deploy other things. And this is where Orkestra comes in. So it understands and creates the diagram of how all your infrastructure and application sits together, and then deploys it out for you. And that's what this does. So the problem that it's trying to solve is prior, when people were doing these deployments, they probably were using CI/CD and then having different pipelines to go install Istio and then make sure that was there, and install, say, Open Policy Agent and make sure that was there. Make sure the database is there, and then they would have stacked Helm charts and some sort of testing in between. This allows it all to be like seamless in the one workflow. So it takes out the complexity of breaking down all your Helm charts. So there's no modification if you're using Helm as at the moment. You can see there that we take the goodness of Argo workflows and we can generate those for the end user, and then we can do the reversal. We've got the automated Helm release management using Flux, so you can roll forward, roll back on certain releases. It integrates with the Argo dashboard. If you want to do on-demand application testing, we can do it with Captain. So what that means is now you can start to roll forward, roll back individual components and do testing on individual components in the complex diag. And yeah, there's auto remediation. So you can roll back to the last successful deployment if something went wrong. So the original use case of this was 5G core, the core network function. So they had a very complex set of needs for infrastructure. They were all on Kubernetes. They wanted blue-green deployment. They wanted auto remediation on failure. So you can see all there. There's a lot that they needed, and they found limitations in Helm, and this is where this project got its legs. So you can see here, this is just a platform dependency. You can see there that they needed the RBAC rules, open policy agent, a bare metal load balancer, Istio. Then they had some state in Redis, and then all the pods were deployed out. So all these applications needed to be there prior to all the components needed to be there prior to the pods being able to spin up, and they needed low latency, and the desired state loop of Kubernetes would make things fail. So this is built solely for Kubernetes, so we haven't extended it out past there yet. I should have turned off my Outlook information. It's a declarative approach, and it's GitOps compatible. So basically what we wanted to do is abstract away the complexity from the end user and just make it feel like a normal Helm workflow. So this is what it looks like for the diags or the DAGs. So you can see that you can have your application chart with application dependencies, and it will use the workflows to work out what it needs. I'm actually an ex-Puppet employee, so this feels very similar to what Puppet used to do for infrastructure back in the day. It builds the graphs and the diag and understands where everything goes, and allows you to be able to map out very, very complex things and deploy it without having to. I have Outlook turned off. Sorry, without having to go through like a full CI/CD. So all the information's in the operator itself. So there is by default we deploy Argo CD but you can change that if there's already a need to change it, like someone else is using something else, but by default we use Argo. We have got an executed container image that allows you to build your own testing or plugin. So it's fully pluggable, like with the ethos of the Kubernetes project. And you can see that it's zero touch. So again, this is again what it's worked on. So you can see that by default, even if the end user uses Jenkins, they'll still have an Argo installation installed, because we're using in the backend, we're using the workflows as part of the workflow for the orchestrator operator. So you can see there that it's going to deploy Argo as well. So this is the roadmap of where we're going. Captain's actually there. We've got that out now. So that's actually in the repo if you go have a look. And this is a quick diagram of how the workflow works for the plugin. So you can see there that you've got just orchestrator, you've got the executor, and it triggers the action in the control plane to deploy out the workflow, and then that deploys into Kubernetes. So the more complex view of this with testing is you can see there we generate through Argo, it's launched, it deploys the Helm release. Captain triggers an evaluation of whatever that is that you've deployed. You can then have your testing systems plug into the query results. You could then have metrics from Prometheus to say if something's successful or not. That could be done on any custom metric in Prometheus you liked. Then you can, once it's reconciled, it goes to the Helm controller and the deployment is met. So you can see there how you can start to break down a whole bunch of complex deployment and testing strategies using the automated Argo workflows and built in with Captain. And yeah, this is just basically a network function. So this is the how the network function operator worked in real life, which is very similar. So you can see there, this is a real life use case of what went on. So this is just the calls between the plugin system and the trigger deploy inside Captain to allow you to see what's happening on the control plane side and speaking to the deployment. I was going to do a demo, but I am actually not going to do that because my computer is running at 100% and I don't want to tempt the demo gods. But if you want to see this running live, let me just go to our. So if you just want to go in and test this out, just go to example. You got a whole bunch here. We'll just go to simple. And you can just deploy this out and it'll automatically create the Argo workflows for you, and you can see what's been deployed there. This is just using the Istio book app. And you can see it automatically create the workflows and build the diag for you of the dependency graph of the application you are deploying. So I rushed through that a little bit quickly than I wanted to, but I didn't want my slides to stuff up either. Any questions?
I have a question, Scott. So I think it seems to be have a lot of dependencies, for the Orkestra. So how you guys handle that, assuming that zero touch?
When you say the dependencies, so the like Captain and like the chart museum and everything like that.
Yeah, it seems to be a lot. I mean, it's basically, to me, the Orkestra is a little bit, give me the feeling it's a little bit heavy. I mean, I know it's powerful, but it's also giving me the feeling it's heavy and can do a lot of things, but it seems to be, I have to use all set of the tools there to really see the thing.
Yeah, so we do take a dependency on a few things, but what we try to do is we control. So for example, like the Argo workflow CD, we'll deploy the version that's needed from Orkestra. You can use that, or you can use if there's a version mismatch, you could use something else. Okay. Chart museum and stuff we deploy and we keep it in our namespace. It's still available to you to use if you wanted to use it, but if there's different versions and things like that. But yeah, at the moment in this stage, there is a dependency on all the upstream components.
Okay.
And Natasha just put a demo in that was done at KubeCon pre-event, and that will show a working demo on YouTube. Thank God for videos when I'm having technical difficulties.
That is great. Thank you.
Any other questions?
You know this question is coming, Scott, don't you? So I'm going to ask it. I can't help notice you had Flux in your code base, and I wondered why not Argo CD.
That is a very good question for Nitesh. Maybe he can answer that in chat. Yeah. I'll see if he'll answer that in chat. If he's there.
One new message.
As he is the architect of the system.
Oh, it says that
just an example. Yeah.
Okay, good.
We prefer, there we go. We prefer.
He says we prefer Argo CD any day. That's exactly the right thing to be saying.
Yeah, we have a dependency on Helm for the Helm controller.
Okay. Great stuff, Scott. Thanks for coming along to show that to us today. You know, we love seeing different use cases for Argo workflows, not just machine learning. It's quite nice to see some infrastructure automation stuff as well, because we do many different things. I will take over now. I'm just going to give people a little bit of an overview, and we only have a few minutes left, so it'll be pretty rapid, of a project that myself, Bala, and Michael have been working on. Intuit gives us a once or maybe twice a year, we get 1 week to work on a specific project that interests us. And the thematic thing for our project this time was to escape from the monolith. So like systems that allow us to break down monoliths. And what we wanted to do was look at plugins as a way to do that for Argo workflows. So the goals for plugins, or the reason to use plugins, and I think these are pretty general to any software, not just to Argo workflows, is that we wanted something to allow people to kind of write code in any language. Obviously, workflows is written in Golang, and but most of our users use Python. So it'd be pretty neat if you could extend Argo workflows using Python rather than Golang. It needs to be relatively simple to do it. So the idea is that plugins actually just runs as an RPC sidecar. We're not wedded to this concept yet. We talked a bit about using WASM as an alternative technology for this as well. But ideally, it should be just very easy to write your plugins and iterate your plugins. In fact, you should be able to start a plugin at runtime and then stop and start it and continue to kind of iterate with it. The other goal is to avoid the need to add the feature directly to the workflow's core code base, which typically means that if you add a feature that get anywhere between, I mean, you might be lucky and there might be like a 1 or 2 month delay, but it could easily be 3-4 months before that release it becomes available generally. So you don't have access to that feature when you want to do it. And finally, I think what's not stated in this list is the ability to extend Argo workflows with proprietary or internal tools that you cannot open source. So obviously there's a whole bunch of things you might want to do with workflows, but a lot of companies can't contribute back to open source due to hashtag security, for example. So what does a plugin kind of boil down to? Well, there are 3 software components inside workflows: the executor, the controller, and the Argo server. And so there are 3 types of plugins: an executor plugin, a controller plugin, and an Argo server plugin. We are not doing Argo server plugins. I'm not even going to talk about that. I think that's a really interesting area as well, but we're really focusing on executor and controller plugins because the controller and executor, the core components really of Argo workflows, and adding capabilities there kind of gives you, that's where all the power is, that's where all the engine is. So adding capabilities there is really useful. So what is it? Well, you basically have to enable them in the workflow controller, and then we'll have a little look at what a controller plugin would look like. So there are a couple of different APIs you can implement as a controller plugin. One is a workflow lifecycle hook, which basically means your plugin will be invoked before or after the workflow is reconciled or operated on. Same kind of thing. And that allows you to modify that workflow or validate that workflow before it's executed. So you could use that to add labels and annotations to it, or perform validation, or build any kind of notification kind of plugins or exporting systems to it. So we've built, as part of our POC, a PagerDuty plugin that reports failed workflows to PagerDuty, or a Slack plugin that reports your workflow status to a Slack room. All those kind of things you can build relatively straightforwardly like this. Then there's a node lifecycle hook, so that ties into node execution. And this is kind of driven by some kind of rather old Kubeflow requirements to basically short circuit the execution of a node or a template within a workflow that allows you to therefore go to an external system before that node is executed, or perform actions around the lifecycle of a particular node. Again, you can do notifications with that, or you can do things like caching, memoization. And another thing it allows you to do is kind of non-pod tasks. So if you don't want to run a pod instead as your template, we can do other stuff as well. And then the third type is a parameter substitution plugin. So it allows you to add your own kind of curly brace parameters into a workflow that people could use. So perhaps that might be some versioning information or something else like that. So this is as it stands today. I think there's a bit of discussion about what the packaging format is, but basically you implement a particular API endpoint and then you send some kind of response to it. So in this example, this Python endpoint will be invoked every time there's a pre-operation. It'll just print out the word hello to the console and then return a response back to it. And that's kind of relatively straightforward. And then I can basically install this Python plugin by using a kind of customized patch. So this is the patch I could use, or it could be my own image. So I'm just kind of taking advantage of the fact that Python is an interpreted language here to actually just kind of put this relatively simple plugin straight into my workflow controller. And then the controller needs to discover plugins. So basically I'll create a configuration map for that plugin, and that just tells me where to find that controller plugin. Okay, so that's that example. We'll just see, do we have an advanced example? Let's click in and see if I've done that. So here's an example of a PagerDuty plugin. So this will send a PagerDuty notification, and this basically gets the old status, a new status in the workflow name. And if it's gone from running to fails, it will then create a PagerDuty event for that service, and that will appear in my console, telling me that I've got a failed workflow if I want to alert on that kind of stuff. Pretty simple stuff. And then this is just the workflow you can run to do that. Then I'm going to look at an executor plugin. Executor plugins are run as part of the executor rather than part of the controller. So they run in the user's namespace rather than the controller's namespace. And so the nice thing about an executor plugin is that as a user, I can configure an executor plugin. That can be something I could configure. I don't need my system administrator to install the plugin for me. And that plugin, of course, is isolated to that namespace. So even as a user, I can write a pretty wonky plugin, and it's kind of contained within that namespace for me. There's only one API endpoint for this, and there's only one kind of plugin you can write at the moment for executor, and I think there'll be another one in the future because it's popular. Upvote issue is basically execute a template. And this example is wrong. So let's go and find a correct example of an executor plugin to show people what that looks like. Let's use the Slack one. So this is a Slack one. This allows me to send an arbitrary Slack message to it. I'll look at the workflow to start with. So this is the actual workflow here. I get a new type of node within a workflow, so not container tag or what have you. It's a plugin, and under that I've got Slack. And under that I've got text saying, workflow has finished, and that'll be parameterized just like a normal workflow by it. And then obviously I've got a configuration here. And so this is my Slack plugin here. Kind of some interesting things about this. Again, I've got a description of this executor plugin. It's not just the address that it should run on, but also the container that it should run as well. And so when the agent is started up as part of your workflow, and the agent's a new feature in version 3.2, responsible for making HTTP requests, the agent is also now responsible for executing plugin templates. So this container will start up as a sidecar. I'm importing some secret data into it, which is really important because that Slack URL is a secret. So that allows me to kind of configure the plugin based on secrets and in the user's namespace or as a user. And then I've got this here. And what this plugin does is it, listens to that API endpoint. If the plugin is a Slack plugin, then it will create a request to the Slack API with the text from it, and that will send me a Slack message. Relatively straightforward. And then finally, it'll respond back with some information about the outcome of the execution of that particular plugin. It'll say that plugin is successful. And that will appear in my node graph. It'll say that it'll show a green tick next to that particular template. And actually the message here will be shown. So I can actually report back additional diagnostic information about the execution of my plugin and the message. And actually, of course, things like inputs and outputs also work with this. So I can create a template plugin that consumes inputs and produces outputs if I want to. Okay, so I wanted to go there to show that. So again, it's 20 lines of Python to execute this, and a bit of configuration, and that's kind of it. And that's really, I just wanted to talk about the failure modes briefly, because that is important for a plugin. And I think that's not kind of a fully the two areas that are not fully explored are kind of failure modes and performance. So basically, a plugin is, the assumption is that when the user writes the plugin, there might be a bit wonky plugin, and that the workflow controller should be tolerant to kind of unreliable plugins that occasionally just error out for an unexpected reason, and that needs to be contained with it. So typically the failures from a plugin fall into whether or not it's kind of like a transient error or a fatal error. And so a fatal error is anything that's not a 503 or some kind of timeout, something along those sort of signs. And that basically results in the workflow failing, which is obviously what you would want for a template invocation. You have the invocation that fails, and you want that to fail. And you'll have some retry strategy on that, so it'll retry again later on. But for a controller plugin, that fatal failure is a bit more serious, and it needs to be contained within inside the plugin itself. Again, the workflow might fail. So there's, like, I think an unexplored area here around what failure means and how we should tolerate that, and what kind of retries we should do, and how we should treat failure plugin. And is there a type of plugin that's a critical plugin which fails the workflow, and a non-critical one which we ignore? You know, if we can't send a notification to an external system, do we fail the workflow, or do we retry later on, or do we ignore it? You know, there's a few options there around that. And then performance is pretty important. We have people talking about running workflows with 100,000 nodes in them now. We know that we have people running 20,000 plus node workflows, and there's basically an order A/B cost to it, where A is the number of plugins and B is the number of nodes. It's quite possible that a very large workflow will result in a very large number of network calls. I don't necessarily want our solution to this to be like we have for Istio, where we always recommend people just disable Istio. It'd be nice to be able to support those ones. And that's where the discussion of kind of WebAssembly comes in, because HTTP call is never going to be fast, even if you're using domain sockets and keep alive. That's as fast as you can go, and it's still significantly slower than an in-process call, like 10 times as slow. So we may want to look at WASM as a solution to allow people to author plugins, but we haven't really explored that either. Okay, you can try this out, by the way. If you want to give it a go, you can go in and pull the pull request and build it and play around with it yourself, and great to hear people's feedback on that.
There was a question about a way to export pull logs from the executors into the Argo controller. I'm assuming this is about the plugin system.
I don't understand this question. Is there a way to export pull logs from the executors into the Argo controller? Yes, but you probably wouldn't want to do that because of scaling issues. Because the Argo controller might be managing, tens of thousands of nodes, even higher numbers than that, and so pulling logs into the controller, obviously that consumes memory, CPU, network bandwidth, so it doesn't scale.
Yeah, what would be? I guess I would ask, what would be the use case for doing this? Because if it's about extracting information from the logs, I would recommend that happen on at the executor level, and then just giving the extracted information to the controller through parameters somehow.
How about we, if you want to follow up, Nitish, with that question, you can obviously come and ask on Slack. That's a solution.
But in theory, I would think it's possible. I think that one thing a plugin could do is recognize the location, the storage location of where the logs were placed. I don't know if they would have access, but I mean, you could give the controller access, and then the controller as a plugin could download and extract the logs. But I don't think I would recommend putting that much burden on the controller.
But also, like, it leads another answer to the question about how do you debug plugins?
Is there a question there? What?
I think it's a question to myself in a way.
Oh, yeah.
How to debug running plugins? The plugin fails. How do I debug that?
Yeah.
Where are those logs? Can I get those in the user interface?
Yeah.
Maybe we should support that. Okie dokie.
Yeah, Alex, if you have another 2 or 3 minutes, I can show the live hook also.
So I think we should probably wrap up on that.
Okay.
Because we're just out of time and people always have 11 o'clock meetings, and we also have an 11:20 meeting that we need to prepare for. So we
Okay,
always
no
wrap up
problem.
those
We
reasons.
can do it next week.
Cool. Okay, great. So just some conclusions. Thank you very much to everybody who has done a demonstration today or a little lightning demo. I want us to do more lightning demos in the future. So if you want to come and do that, that's great as well. On web, I've written web rather than wed. Wednesday, the 15th of December, we'll have Andre and John from Kuflow KTIB, and they're going to be doing a kind of presentation and demo for us as well. So I think that'll be pretty neat. As I mentioned, the video will be up on YouTube. If you do want to present or do a demo, you just reach out to us on Slack, myself or Bala, and we can sort that out for you. If you want to get more involved, for example, doing blog posts or anything like that, just reach out to us if you want to do more of that kind of stuff. That would be great to hear from people on that. Okay. Anything else? I think we're good.
Thank you, Alex.
All right. Thank you very much, everyone.
Thank you.
Yes.